Cool. All right, team, let's begin. So let's get the answer for our do now. I pulled it up off of the NZQA website because it is an NCAA style question. For the first question, you should have identified it as an exothermic reaction and then any justification that we are looking for. So recognizing that the main thing I would say is that you notice that the enthalpy is a negative value. That's how you know. This one is an achieved point with some sort of reasoning. So saying energy is released, or I notice the delta H is negative. Every so often I see it as a merit point sometimes. I don't know if it's just because they're trying to make more merit points in the marking schedule. And usually what they're looking for then is they want to make sure that you explain your process. So explaining that you figured that out based on the fact that it is a negative number. All right. For the second question, let me kind of walk you through how you're supposed to decode it. Like I said earlier, I really don't like this question because I think it's overly difficult and like confusing, like in an unnecessary form. This is not taken from a mock. This is taken from an actual exam. I know sometimes the mock questions we give you are a little bit harder than the actual exam questions. And the reason why is to basically prepare you for things like this that might happen. This is a very confusing question. The reason why it's very confusing is because they're giving you two equations here. And the two steps are linked to, or sorry, the answer is linked to doing two steps using each one of those equations. And it's really easy to just grab the wrong number kind of situation. There's also a lot of language that you need to read and decode from it. So like I was saying earlier, the first step of this question is asking how much energy is released when you have 20 grams of lithium bromide, because we need that answer to be able to do this second question here, which is asking to calculate the mass of the potassium bromide to release the same, or sorry, to have the same energy change. It's also confusing that both of these are, like, one's exothermic, one's endothermic, so be mindful they were asking for the same energy change. So just, the same value of energy change. So in this case, one is releasing that much energy. How much potassium bromide would you need to absorb that same amount of energy? So if we were trying to like balance the two out. For this one here, you guys should have gotten, oops, let me grab a different color. You should have gotten 11.2 kilojoules of energy as your answer. I'll pull it over to the marking schedule so you can see kind of the working. So what they've done is they've done the 20 grams of lithium bromide. They divided it by the molecular mass of lithium bromide to get the moles. And then they've done the moles times by the enthalpy. In this case, we don't need to divide the enthalpy by any number because the equation has only 1 mole of lithium bromide. But if you divide by 1, you still get the same answer. I personally keep those steps in to make sure I know what I'm doing. All right. So again, it's just about grabbing the right numbers. So lithium bromide, we wanted this number, we wanted this number, and we wanted this number. So you got to watch questions like this because it's a different questions that, or sorry, different calculations that you would get. All right. Let's talk about the second half of this question then and how we work backwards. So in this case, we are trying to calculate the mass based off of the energy that we know. So our first step is we want to check to make sure that we have the energy in, what's the word I'm looking for? In per mole. So we want to check that we have the energy value in per 1 mole. So that's my first step. So in this case, I would be using the 19.9. I'd be looking at the front of the potassium bromide because that is my moles. In this case, the number is 1. So I'm just dividing it by 1. It's basically the same answer. So I'm working with 19.9 kilojoules per mole for the dissolving of my potassium bromide. Are we okay with that so far? So basically it's similar to what you were doing before, it's just in a different order. So divide it by that so that way we can figure out per mole. Second step then is I want to figure out how many moles I need to release or absorb that energy. So what I'm going to do in that case is I'm going to take this energy value, because that's what we were saying, in reference to the lithium bromide, what is the same energy, what's the same amount to get the same energy change. So I have 11.2 kilojoules, and I'm dividing it by what I had from number 1, 19.9 kilojoules per mole. It's really useful to write down the units so that way I can double check to make sure I have things in the right order. So I'm canceling out my kilojoules, and I have per mole. Since I have per mole, I then have mole. Sorry, don't do that. All right, so 11.2 divided by 19.9, I have that my mole value is 0.5625. I'm just going to write ... There's a lot of numbers there, but I don't want to round until the very end. So that's how many moles I need to release that amount of energy. But the problem I'm running into is that the question is asking to calculate the mass. So I need to, step 3, convert from moles back to grams. So if we have N equals M divided by big M, I want to rearrange that. And so mass would equal the amount times the molecular mass. So M is equal to the number I got in number 2 in moles times by the molecular mass. And in this case, I want the potassium bromide. So 119. And again, I like to write units, grams per mole, so I can double check that I've rearranged my equation correctly. I see moles and moles cancel, so I have grams. So I have rearranged it correctly. Do you want me to go back? Where do you want me to go back to? Yeah, so when I rearranged it, what I did was I wanted to get mass by itself. So in order for me to do that, I would multiply both sides by molecular mass. Oops, that should be a little m. Hold on, what am I doing? Yeah, multiply both sides by molecular mass. What am I doing? Hold on. How did I get that equation? Oh, now I remember. All right, so I had N equals M divided by big M. If I multiply both sides by big M, I get rid of the big M on that side, and then I have mass equals the amount times the molecular mass. That's how I rearranged it. Yeah. The other option is you can plug in the numbers and you can rearrange it that way. So if I wanted, I could do 0.5628 ... equals M divided by 119. And then I could just multiply by 119 on both sides. It's the same calculation, whichever way you guys prefer. Same way. All right, so I do that times 119. It's really good to leave your numbers in your calculator so that way you don't have to like copy anything down. So what that tells me then is mass-wise, I would need, now we got to play the game of rounding. So let me make that a little bit brighter so you can actually see my calculator a bit better. You guys see my calculator okay? Great. So you see how it says 66.97 and then lots of numbers. I want 3 significant figures. So I want the 6, and the dot, and the 9, because that would be 3 sig figs. When I look at the 9, I go over to the 7. The 7 tells me to round up. So I'm going to be rounding to 67.0 grams. And now that's 3 sig figs. Yeah. Sorry, this is bothering me. All right, questions, concerns, comments? Make sense? Okay. Let me show you the marking schedule so you guys are aware of how the points broke down. So, achieved. Again, they usually give you multiple ways to get the achieved because they're trying to give you the benefit of the doubt. So, correct number of moles for the lithium bromide is one way they would give you the achieved. So that's getting the first, sorry, that's even like way before. That's that conversion. The other thing is the correct mass of the potassium bromide from incorrect numbers of moles. So I guess it means that you've made an error somewhere and that you've carried through that error and your answer is right based off of the error. So watch your transcription errors. So like when you're copying things down, when you're entering things into the calculator, if you make that mistake, it can drop you all the way down to an achieved. So just be mindful. They're not as kind as internals. If it was an internal, we could use holistic evidence to go, this is just a calculation error. They've just copied the number down wrong onto their calculator. On the exam, they are not kind like that because we don't see all your other work. We can't give you the benefit of the doubt. The other thing for the achieved is correct energy change. So getting the 11.2 value. Or correct mass of the potassium bromide, you've made a mistake in the energy change component. So this just means that you've made the mistake later in the calculation. So basically, how early do you make that mistake is how they're gonna decide what they give you. And then for the excellence is the correct mass calculated. And in this case, they have nothing stated about significant figures or units, so that's really kind. And I guess the reason why is because they've given you other things to distinguish between the merit and the excellence level student. So, but it's still good habit to make sure you have the significant figures and the units because it might be on the marking schedule. Just kind of depends. All right. The other thing I wanted to state as a nice little reminder is show your working, because if you get the wrong answer, if the examiner can backtrack to figure out where that wrong answer or where the mistake happened, they can give you some points. If you just have an answer with no working and the examiner can't work back, then they won't give you any points for it. They'll just think you wrote a random number down. Okay? So, plan then is I'm going to give you some new questions. I've given you two. One is the 2012 exam, and then the other one is from the 2020 mock. They're on the same piece of paper. The reason why I've selected these exam questions is because they are a little bit trickier, and I don't want you guys to be stumped if you see something that's a little bit weird. So that's what we're going to be working on, and then I will go through and do some clarifications on it. I'll see how you guys go. We might do 2021 first, and then 2020. So that way you guys can get a little break from me talking. Okay? Cool. I'll go pass it out.